Hi everyone! Today we're going to start by discussing acids and bases, which is in chapter 16 of your textbook. Now, some of this might be review, but it's always good to remember the basics before we go on to the more difficult concepts. So let's start by discussing a real-world example of acids and bases and how they can affect us. So you might have experienced heartburn before, and that's due to the acid that is in our stomachs. So the cells that line our stomach naturally produce hydrochloric acid, and it's just enough hydrochloric acid to kill any unwanted bacteria or help break down food. This hydrochloric acid can also activate what are called enzymes that also break down food. Now, if that stomach acid backs up into our esophagus, it irritates the tissues along the esophagus, and that can result in heartburn or acid reflux. In order to cure heartburn, we can use different products like Tums or Pepcid. There's also Rolaids or Alka-Seltzer. And all of these different products contain neutralizing materials. Now you can also just swallow your saliva, which naturally contains bicarbonate ions. And if you don't remember what those look like, bicarbonate is HCO3-. Antacids, like the ones shown below, will contain hydroxide ions, OH-, and or carbonate ions, CO3 2-. And all of these different ions can help neutralize stomach acid. If it's been a while since you've looked at polyatomic ions, I encourage you to brush up on those. So let's talk about some properties of acids. Acids typically have a sour taste, so one common example is citric acid, which is in lemons and limes, and other fruits as well. Acids also can dissolve many metals, they can neutralize bases, and they change blue litmus paper to red. So down below, if we were to put blue litmus paper into an acid, we would see that the paper changes color. And the same thing happens with a base. So if you start with red litmus paper and you place that in a basic solution, you can see that it changes color to blue. So kind of a cool property there of acids and bases. On the left, we can see an example of an acid called acetic acid, and this is what's in vinegar. And on the left side of this molecule, so if we look at the Lewis structure, we have a hydrogen next to an oxygen. And we know that oxygen is relatively electronegative. So in this Lewis structure, we could draw a partial negative charge on oxygen. And that means that hydrogen will be partially positively charged. So oxygen is drawing electron density away from hydrogen. And this is actually going to affect the molecule and how it reacts with other molecules. So we'll talk about that a bit later. All right, now let's go through a list of common acids, and this table 16.1 can be found in your textbook. So hydrochloric acid we already talked about. Sulfuric acid is used in some manufacturing processes. So for instance, in the manufacturing of fertilizer and explosives. It's also used in automobile batteries and the electroplating of copper. Nitric acid is similar, and we talked about acetic acid, which is in vinegar, and citric acid, which is in citrus fruits. Carbonic acid is found in carbonated beverages, and hydrofluoric acid is dangerous, so this can be used to etch metals, for instance, or glass. And then phosphoric acid is used in the manufacturing of fertilizer. It's also found as what's called a buffer. So we'll talk about buffers later on. But I would like you to know the names of all of these acids. Now, if flashcards help, I have posted a link to a set of flashcards that are online. So if you don't have index cards handy, for instance, you could use the online flashcards. But the other way to remember the names of the acids is to go back to Chapter 3 and review how to name them. Now, there are two different types of acids. The first type is called a binary acid. And binary acids have a hydrogen ion attached to a nonmetal atom. Now, we're saying hydrogen ion here, but really these atoms are covalently bonded. So, for instance, we have hydrochloric acid, and I'll just write a note here that these are covalently bonded. So they are sharing electrons, but we do have our hydrogen atom bonded to our nonmetal atom, the chlorine. And this follows for other types of acids as well. So hydrofluoric acid, HF, is another binary acid. There's also HBr, hydrobromic acid, and HI, hydroiodic acid. The other type of acid is called an oxyacid. And in this type of acid, we have a hydrogen attached to a oxygen atom. So typically, this involves hydrogen atoms bonded to polyatomic ions. So for instance, H2SO4, sulfuric acid, this has two hydrogens bonded to the sulfate anion. And then nitric acid has a hydrogen bonded to the nitrate anion. So I'll just write down below sulfuric acid that we have a hydrogen plus the sulfate ion. Well, we have two hydrogens there. And then for nitric acid, we have a hydrogen plus the nitrate ion. All right, so remember that there are two types of acids, and naming the acids depends on the structure. So if we go back to our table, we start with a binary acid, hydrochloric acid, and you'll notice we're using this prefix hydro. And then in sulfuric acid, we have a polyatomic ion, so this is an oxyanion, or an oxyacid, excuse me. And we're going to use the base name of the sulfate there and add ic acid. And that trend continues for the other acids as well. So remember to go back and review how to name acids, and also remember to check out those flashcards. All right, so now let's talk about some structures of acids. So one type of structure that's pretty common for acids is the one shown on the right. So here we have the Lewis structure for what's called a carboxylic acid group. And this is found in different types of acids like citric acid or malic acid. And the piece on the right-hand side here, that's indicating that there's some sort of group attached to the carbon there, but we don't know what it is. Just in general, if you have a carbon that's bonded to two oxygens, and then one of those oxygens is bonded to a hydrogen, that is a carboxylic acid group. Now, only the first hydrogen in that group is acidic. So we talked about earlier that the oxygen is partially negative, the hydrogen is partially positive. Now, the fact that that hydrogen is positive means that it could potentially leave and go to a different molecule. And then oxygen will be super happy because it will gain the electrons from hydrogen. So after a reaction, we might end up with a hydrogen ion and our carboxylic acid group that's bonded to something, but it has a negative charge. Now let's talk about some properties of bases. Bases taste bitter. So if you've ever heard of alkaloids, those are chemicals that come from plants that are basic, and they're often poisonous, so you do want to avoid those. Bases also feel slippery. So if you've ever cleaned something with bleach and let's say you weren't using gloves, you might have felt that the bleach was kind of slippery. Detergents are also basic and those tend to be pretty slippery. So if you've ever touched laundry detergent, for instance, it's got a slippery feel to it or a soapy feel. Earlier we saw that bases can turn red litmus paper blue, and similar to before where acids could neutralize bases, bases can neutralize acids. And then off to the right we see some common basic products that you might use around the house. So liquid plumber, for instance, or Comet, Drano, etc. All right, now for common bases, and this table can also be found in your textbook. We've got sodium hydroxide to start. This is used in soap manufacturing. Potassium hydroxide is used in electroplating. It's used in batteries. Sodium bicarbonate is baking soda, so you can use that in your cooking. You can use it as an antacid. Sodium carbonate, it can be used as just a cleaning product. And then ammonia can be used in detergents, and it can also be used in the manufacturing of fertilizer and explosives. So I would also like you to know these names. And if you need to use flashcards, I've included those in a link on Canvas as well. All right, now let's talk about some definitions of acids and bases because there are multiple definitions. The Arrhenius definition, to start, tells us that an acid produces hydrogen ions in solution. And those hydrogen ions will associate with water to form what's called a hydronium ion, H3O+. And then the Arrhenius definition also tells us that a base produces hydroxide ions in solution. Now the Bronsted-Lowry definition is another way to describe acids and bases, and in this definition it's a little bit different. An acid donates hydrogen ions and a base accepts hydrogen ions. So let's dive a little bit deeper into these definitions. So we'll start with the Arrhenius theory, So we said that according to this theory or this definition, acids produce hydrogen ions in aqueous solution. So a great example is hydrochloric acid. And we've seen previously that hydrochloric acid is an electrolyte and it dissociates 100% or near 100% in water. So we have our hydrogen ions and then we have our chloride ions at the end. So nice and simple, acids produce hydrogen ions. Now, in addition to that, those hydrogen ions can team up with water and form hydronium ions. So hydrogen ions that are produced by an acid, like hydrochloric acid, are really reactive. So they don't actually exist by themselves in solution. So down below, we can see how these hydrogen ions react with water. So a water molecule can grab onto that hydrogen ion and form the hydronium ion, H3O+. And then down below we have the Lewis structures for water and for the hydronium ion. Now, if you remember how to calculate formal charge, you can figure out where this positive sign is coming from. Is it on one of the hydrogens or is it on the oxygen? So that's an extra challenge. Now, according to this same theory, bases produce hydroxide ions in aqueous solution. So again, we've seen this example before of sodium hydroxide, and that will produce sodium ions and hydroxide ions. And I'm actually missing my negative sign there. All right, so nice and simple. Now, what if we add an acid and a base together? So before we said that acids and bases can neutralize each other according to our definitions or properties of acids and bases. And in particular, the hydrogen ion from the acid is going to combine with the hydroxide ion from the base. And we'll end up making a molecule of H2O. So you might remember from previous courses that in a neutralization reaction, which is what this type of reaction is, we have our acid and base that combine, and then our products will be some sort of salt and water. So again, remember that the hydrogen ion from the acid, so in this case, hydrochloric acid, is going to team up with the hydroxide ion from the base, in this case sodium hydroxide, and those are going to form a water molecule, which will be neutral. And then whatever's left over becomes our salt product. So that's NaCl. So again, we can call this a neutralization reaction. Now, luckily for us in this reaction, we didn't have to balance anything. Everything worked out really well. But sometimes you can have a base that contains 2 hydroxide ions or an acid that contains more than 1 hydrogen. So always be careful with balancing neutralization reactions. Now, I think we're going to stop there today, and next time we'll talk about the Bronsted-Lowry theory of acids and bases. But for now, definitely go back and review the names of acids and bases, and also their properties, and we'll continue our discussion in the next video.